4.6 is about functions, but before we begin on 4.6, I want you to try this problem, and we'll go over it in class tomorrow and we'll see how you did. So I want you to find the intercepts. You can write this on your notes. Find the intercepts of this equation. 2y equals 4x minus 8. So when I say find the intercepts, I mean find the x-intercept and the y-intercept. So bring that to class tomorrow. We'll see how you did on that. Okay. We're going to begin with our first definition. We can put this straight onto our Cornell note sheet. A function. So instead of putting it on your notes page, put it on your Cornell note sheet. You can put it in both places if you like. Is a relation. It's a special kind of relation where each element of the domain, which remember are the x's, is paired with exactly one element of the range, which are the y's. Okay? So a relation where each element of the domain, or the x's, is paired with exactly one element of the range. So that's words. What does that really mean? Okay. Here's an example of a function. Here's an example of a relation that is not a function. These are both relations, but once you have relations, then you can divide them or categorize them as functions or not a function. Now you can see that each element of the domain here, x, or the domain, is paired with exactly one value in the range. So each one of these is paired with exactly one. That makes it a function. Look at this one. -9 is paired with -4, but 6 is paired with -1 and 1. And 11 is paired with 3. So right here, where you see two arrows coming out of the domain value, or the x value, that is what makes it not a function. So a function can have two x values that point to the same y value, but you can't have two y values coming out of the same x value. So when you see an x that repeats with two different values, that is what makes it not a function. Now, if you look at it in a table, so if we were to write this in a table, it's -9, -4, 6, -1, 6, 1, and 11, 3. You see a repeat in the x values. That makes it not a function. Or if it were written as a list, you can see the repeat in the x values. So a function, there can be no repeat in the x values. And we'll go ahead and add that up here. X, we'll say this, if x repeats, it's not a function. Now there's no care about y. Doesn't matter if y repeats. But if x repeats, it's no longer a function. Okay. Another way you can tell if something is a function or not is to use what's called a vertical line test. Okay. So if you can draw a vertical line through it and it doesn't cross the relation in more than one place, then it would be a function. So we can go ahead and write that here so you understand. If a vertical line crosses more, let's say crosses the relation in more than one it is not a function. So if it crosses over the relation more than once, then it's no longer a function. So imagine if you draw a whole bunch of vertical lines. what you're doing is you're checking the x values. So at this x value, it only crosses once. At this x value, only once. This x value, only once. And the same thing throughout the whole thing. So since it only crosses the relation only once, then it is a function. Okay. Now in number 2, as soon as I draw one vertical line, I automatically see that it crosses the relation here, and it crosses the relation here. And if you imagine what those points would be, that would be, well, let's use this one and this one maybe. This might be, we'll say, 1.5 and 1.5. 1.5, 1.5 would be that point. This one would be 1.5 and -1. So you can see the x values are repeating, and that's what the vertical line is testing. So not a function. Go through these last 4 and see if you can figure out if it is a function or is not a function. Go ahead and push pause here. Try these on your own.